All right, no more toys.
What?
Stuff. This is a push rod. It's for hydraulic or solid?
Hydraulic.
It's hydraulic, as I can see it through there. So, and if you want to know if it's long or short, just look down here. There's a 73411 push rod. Standard or long? Standard. It doesn't say P anything, so it's standard. And then while I was in there, I got some dirty rocker arms. Let's see. Lycoming rocker arm. You can see where the push rod is going to go up into here, go inside there. The bushing has a, what's that word? Annulus. Has a little anus in there. Annulus groove. This allows the oil to go around and spray out of that little hole. Pass around with dirty. Let's see. Your style, I can tell because got adjustment. So what yours does is it's going to sit, came up high, so it's going to sit this way, and it drips inside of that little hole right there, and that lines up with another hole in the bushing, so it drips in there, and then drips on to the bushing inside. That's all it gets, is a little drip oil right there. That's for it. This is a Continental, small Continental one that would actually go on this particular cylinder here. Fit. You can. This one has the annulus on the inside, but same thing. Pressure through here, goes through a hole. You have to line up the hole in this one. Put the bushings in, you screw up, and it goes around, and then it comes out here, and it actually pressure oils through the foot. So it's like that. So it's like, well, how does it get down there? Well, it doesn't. It goes this way on the Continental. Because push rods come this way. It's this way. Lycoming, Continental. So it comes out of here, drips down that way. And let's see, same thing I showed you. I picked up a pretty large Continental angle head. So you can see this one is like, it's not straight, it's angle. Most of our cylinders are angle head. So you have an intake side and exhaust side. Sometimes the Continental, or like Lycomings, they do have an intake side and exhaust side, and it has to do with that pressure oil. So the ones that have the pressure oil go on the exhaust, the ones that have the drip go on the inside, intake side, and that's that. And what do you suppose this funky thing is?
It's the cam ring.
Cam ring. It's 2 tracks. One track is for
Intake.
the other side's for exhaust. So yeah, one side's for intake, the other side's for intake. No, intake, exhaust, intake, whichever way it goes. And what kind of tappet would go on this?
A roller.
Roller. Generally speaking, solid. All right. What else do I got here? Let's finish off our slides. All right, we did a compression test earlier out in the shop the other day. Okay. This particular one is the E2M tester, and it's got 2 valves on it. This one says master orifice. Do you remember what the master orifice was? Kind of a calibration thing. So if we look at this particular drawing here, it explains a little more. You used to have to buy a master orifice from Continental. They're really expensive. So much so they came in a little wooden box, a little velvet line in there, and a little cutout, and you'd fit in there. And very expensive. So the idea behind the differential compression tester is that as air comes in, this first gauge is how much air you're getting off the compressor and through the line. So you can see there's no restrictions. Just comes in, boom, that's what you got. That's what you're getting from the compressor past your regulator. So you can turn it up, you can turn it down. So that's inlet. Then it's going to go across to an orifice, into the cylinder. And the cylinder is going to leak or not leak. And it's that leakage that this registered. If it had zero leakage, then this would read the same as that gauge. They would read the same. But if you get leakage, the more leakage you get because of the orifice across there, the lower this will get, and that's what you're looking at. So this represents, well, first of all, put a master orifice on, turn this all on, turn this to 80 and see what that says. Write that number down. Then go ahead and do it on the cylinder, and hopefully this reads better than the master orifice. Hope you followed that well. But instead of now buying a tool in a velvet lined box, this company makes this one. So we pressurize, go to 80 psi, open the master orifice, leaks across the orifice here. Whatever stays on this side past the master orifice is our standard. So it's usually about in the 38, 40 range is usually what I see. So, which means that if your cylinder is better than, if the master orifice reading is 40, as long as your cylinder is better than 40, you're fine. But that's Continental. Lycoming is very, very different. Like I said, I think Larry's going to cover most of this, so I do not need to really go over it. And I will let him do that. Let me see. But just to give you an idea what we're talking about. Let me see. This is out of Continental. It's like, so you did a compression test, little pamphlet, and what does it mean? So I told you listen for air discharge, and this one says, well, air discharge at oil filler crankcase breather. So where's my leakage? Piston rings. So I'm like, all right, got leakage past the piston rings. Good luck trying not to get that. You're almost always going to get that. So remember, this is Continental. So then you're going to look, well, what did my pressure test indicate? Reading above acceptable, or reading below acceptable, below acceptable. Okay, so let's just say it's fine. Reading is above acceptable. Then we do a borescope. Borescope's normal, oil consumption stable, no excessive oil discharge. Recommended action, continue in service. Check it again next annual 100 hours. Make sense? Okay, so now we do it and we have test below the acceptable. So I did the master orifice. Master orifice reading is 40. Okay, that's my standard. Take off the master orifice, plug in the cylinder, do diff check, and I got, oh no, I've got 36. And it's leaking through the breather. Well, what do I do now? Do borescope, normal borescope, oil consumption stable, no excessive oil discharge. What do I do now? Fly the aircraft at cruise, power setting, and repeat the cylinder check. Now that's a tricky one because if you're doing an annual, yeah, you either sign it off as airworthy or you don't, which would mean you'd legally have to sign it off as airworthy and then go fly it, and then, so very strange. Yeah, so oops. So, all right, if we got a below reading and we did a borescope and we had a green valve, then that would be burned but not acceptable, so remove and repair. Let's see, differential pressure test reading above or below the acceptable cylinder pressure leakage. Oil consumption, anytime you have abnormal consumption, discharge out the breather borescope, okay, that's a whole other thing. Let's see, little or no air discharge at the crankcase, abnormally high. I'm big, go with it.
That's good.
Yeah, I'm happy with that. But that talks about if you have oil consumption, abnormal, borescope reading, abnormal. Air it into the induction system. Let's see, so that was breather. What happened if it's leaking through the intake valve? Test reading above acceptable. Normal cylinder borescope inspection, we continue in service. If it's below the acceptable, borescope's okay, then we fly it again. Exhaust leakage. Differential pressure reading above master orifice. Borescope normal, we good to go. Below acceptable, good borescope, there you go.
How
Um,
do you get air discharge into the exhaust with a high differential pressure?
Which one am I looking at? 1, 2, or 3?
That one that you just.
Second one.
This one? Cylinder differential pressure test reading below acceptable.
No, above
Above
it.
it, sorry.
Here, cylinder differential pressure test reading above the acceptable cylinder
During the
pressure,
leak in the exhaust.
above the acceptable leakage limit.
Oh, okay.
So the leakage limit was 40, so it's above 40.
I can still be leaking.
Still leaking.
All right.
78, 68, 42. So with the Continental, they're saying, hey, you got 42 over 80. Now these Lycoming guys, they just ruined their shorts. Continental guys were like, 42 over 80, 40 was my minimum. I don't care. Borescope looked good, no green valves, everything, burnt pizza, normal looking. What am I going to do? I'm going flying. Not these guys. Let's see, air escaping at spark plug. I tell you, that's going to be bad. Differential test readings, not it's just if you get air at the spark plug spot face, you got problems. Cylinder head to barrel junction. I'm not flying that. I don't care what this says. All right, let me see. Oh, this is 4313. So that was Continental. You guys follow Continental? Master orifice. If it's above master orifice, you're pretty much good. If it's below master orifice, but the borescope looks good, you're pretty much good. Fly it, recheck. 4313. When can I use 4313?
No other data.
No other data. Do I have other data from Continental?
Yep.
Do I have other data from Lycoming?
Yep.
Then you ain't reusing this. And if you do, you're going to be in trouble. But it says, let's see, compression testing. A test to determine the internal condition of the combustion chamber cylinder assemblies by ascertaining if any appreciable internal leakage is occurring of a compression test aircraft engine cylinders. If the cylinder has less than 60 over 80, how does that work out for Continental? Yeah, nope. Reading on the differential test gauge on a hot engine and procedures and paragraphs, blah, 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 fail to raise the compression reading. The cylinder must be removed and inspected. So what is 4313's magic number? 60 over 80. Let me see. Yeah, 4313. The I and the J, this would have said. Observe the pressure. Let's see, pressure. Loss in excess of 25%, which I think is 60 anyway. Leakage being defective. Recheck after operating for 3 minutes. So it's below 60 over 80. I had to take it out and ground run it for at least 3 minutes. Leakage is still occurring. It may be possible to correct a low reading accomplished by placing, this is called staking the valve. It's kind of fun because it's loud. So if the leakage is still occurring after recheck, it may be possible to correct a low reading. This is accomplished by placing a fiber drift. What is this called again?
Sticking the valve.
Staking the valve.
Staking.
Basically, you do a compression test on the engine. While the pressure's going in there, and you're looking, you have your friend doing it, you're like, oh, yeah, we're at 50 over 80. You take off the rocker cover. You got your rocker arm sitting in there. You take a fiber drift, you put it on there, and you'll whack. And all that pressure is boom out the exhaust. And it pops it down. If there's any carbon in there, it'll blow it out, and then it hammers the valve back up on the seat, and in theory should seal it. Sometimes it works. Sometimes your valves get a little egg-shaped, and because they rotate, it'll only seal when it falls back in the egg-shaped seat. And so it's off a little bit of its egg, and you do it, it pops into the egg shape, which is kind of, I don't want to say cheating, it defeats the purpose. But anyway, dislodge any foreign material. The idea is that you're dislodging foreign material. Do I not really talk about Lycoming? Apparently I don't. Okay, well, how about that? Lycoming.
So is 80 just a random standard number? Or
Yes, it is. Yeah. All right, Lycoming. Let me see. Lycoming. Service instruction 1191 alpha. By the way, there are different, these compression gauges. They have several different types, and they have a board. This orifice right here is different sizes in them. And so Lycoming is very specific to use the 040 orifice, which is the E2M. which is ta-da-ta, that one. So this one works for Lycoming. Let's see. They want the difference between each cylinder. This is what's nice to have a Continental. So I have a Continental. Oh, we'll go back to that. So Lycoming says pressure. First of all, they want the pressure within 5 psi of each other. No thanks. All right. Then, if it's 10 to 15 difference, investigate. Let's see. Overall, anything greater than 70 is satisfactory. It's the best you can get with a Lycoming, satisfactory. If it's less than 65, recheck in 100 hours. If it is less than 60, consider overhaul.
Consider but not required.
Yes. Huh. Yeah, no.
That's all it took.
Put in the logbook, I considered it. You can get specific. I went downtown, I had a beer at the bar, I thought about it, my wife said no. But yeah, look at, I mean, isn't that crazy how, so Lycoming seems to follow 4313 quite well, because if you do the percentage they want, it falls in line here. But there's Lycoming. Continental, it's master orifice. Oh, I could do it this way. Just remember the master orifice reading. We'll do the master orifice. First, you get a master orifice reading, which, like I said, by experience is usually around 38 psi. So 80 over 38. I'm sorry, 38 over 80. So if it's greater than the master orifice and bore scope is okay, satisfactory. Satisfactory. If it's less than master orifice and bore scope is okay, you are satisfactory. So less than master orifice and bad scope, then fix. Then you have to fix it. Yeah, fight some more. So that ends up being like, so that's 70 over 80, 65 over 80, 60 over 80. So that's these guys over here at their Lycomings. I'm over here going, yeah, 38 over 80 is my master orifice. So 40 over 80, I'm satisfactory. 36 over 80, bore scope good, I'm satisfactory.
Better tolerances.
So until the bore scope is bad.
Till the bore scope's bad. The Continental's really more about just do a bore scope. That's really what we want you to do. All right. I wrote this in here for some reason. This must be a Q&A. By use of a differential compression tester, it is determined that the number 3 cylinder of a 9-cylinder radial engine will not hold pressure after the crankshaft has been rotated 260 degrees from top dead center compression number 1. How can this indication usually be interpreted? Why is it normal?
That's the correct answer.
I was hoping somebody would say that. So I will tell you the secret to this. If you want it or not, here it goes. The Q&As, the secret is, if you don't know why, that's where you need to be looking. Why? It's always the why. Because I have been told, and through some personal experience, when I took the IA test, again, I went through and memorized all of the questions and all the answers, pretty much. I mean, you know, I could have told you they're very difficult. They weren't that easy. But the thing I did is I made sure I understood every single question and why it was. A lot of them have to deal with charts, reading airworthiness directives, but I knew why, exactly why. I know how you got that answer, why you got that answer. So what I've been told, then when I went to take the test, I did not recognize a single question. Not one question was the same. They were all worded differently with different answers, but the why never changed. It's like their explanation for the questions was the same. So if you knew the explanation and understood it, the test was not hard. I have been told by students taking the test now that the FAA has really gone to this. So I'm asking them, you know, before it was, did you recognize the questions? Recognize them? Hell yeah. I saw every one of them was like, duh, I've seen this one 100 times. Now they're saying, no, I didn't recognize but 3 or 4 of them. But the idea was there. So be very careful if you're like, yeah, it's just normal. Why is it normal? I have no idea, but man, I'm good to take the FA test, right? Also, on Monday, I need to record all this. All right, goodbye. I'll let it run. So on Monday, Denny's going to come and talk about the new airman certification standards, but we'll be in here unless you really want to go down there. But in reading some of the stuff from DMEs, and this has been going on for a little while, they're saying that your oral practical will consist mostly of what you miss on the writtens.
Yeah. So it's just like if you're private.
I've heard the private went that way a long time ago.
Yeah.
Yep, whatever you're weak on your writtens, that's what they're going to hammer you on practical. So I was talking to a guy on the phone the other day. He's a Coast Guard guy, and you know, never worked on recips. I said, man, if I were you, I would bomb the turbine side. Just everything you know, just get it wrong on purpose. That way, that way when you oil practical, it'll be nothing but stuff you know, right? And it's like, really? I'm like, no, don't do that.
No, don't do that. Try it, but don't do it.
Yeah, but I also saw something about if you like ace the tests, then you're going to have very few questions. It's like a really easy oral practical. So do with that information what you want.
And that's where it's opposite from flying. If you ace or get like 90+% on your written for your private, they hound you again because it shows that you know it all. So they'll sit there and pick.
Oh, tell you, find your weak spot. All right, so
It's in there somewhere.
this question talked about 9-cylinder radial engine. Oh my gosh. 1, 2, these are cylinders. 3, I don't know how many I'm going to fit on here. 4, okay, that's good enough. So,
Alright.
because we're only talking about 1, 2, 3. Here's the propeller. It's going to be taller, but I want you to see it. So in radial engines, propeller is going to point to this. When you're top dead center of number 1, one of the blades is going to be pointing to it. It's not when the blade is pointing to it, it's a top dead center. It's when it's at top dead center, one of the blades will be pointing at it. So I just did a compression test on this engine because it was at top dead center. What's the firing order? 1, 3, 5. That's all we need to know. So what's the next one that's going to go to top dead center? Okay, so to get it to 3, I'm going to rotate it to right here, right? So the question talks about the fact that you rotated it 260 degrees. Well, let me see, that would be 180. Is it top dead center of 3?
No.
270 be right there. So 260 be right there. So I've rotated it. Instead of going from 1 to 3, I went 1 all the way over here to whatever number that would be, 7 or 8. And it says, so differential compression testers determined the number 3 cylinder of a 9-cylinder radial engine will not hold pressure after the crankshaft has been rotated 260 degrees from top dead center compression stroke from the number 1 cylinder. How can this indication be interpreted?
The other side of the propeller is on 3, what you're saying?
No. Here's the prop. Got it?
Yeah.
Propeller. Is it the drawing that throws you off?
Yeah.
Is it? Let me see. Let's go back one. Let me see, where's my PowerPoints? Week 1. There we go. Better? Okay. This is 1. This is 2. This is 3. Okay? I don't know which cylinder's on top dead center of compression. It's either going to be this one or that one, just because I know how these work. But when I put the number 1 cylinder, top dead center of compression stroke, guess what is going to be covering the cylinder? A propeller blade. So let's just say it's this one. So if I move this one to right here, top dead center compression, the blade is right there. Okay? What's the next one in the firing order? 3. How do I know when I'm on 3? I move the propeller blade to right here. That's how I'm going to do my compression test on this. Then after that, I'm going to move it to here. Then I'm going to move it to here. Follow? Then I'm going to move it to here. Then I'm going to come around again. And it's going to go from here to here. Then it's going to come over to here. You follow? You sure?
Yeah.
Okay. So, a minute ago, I had the propeller right here, and I did a compression test, and it was 70 over 80. Sound good? Sounds good to me. And I rotate it now 90 degrees. What cylinder's on top dead center of compression stroke? 90?
It's 80 degrees apart. From 1 to 3.
Okay. He's right. It's still beyond top. It's still beyond compression. It would just you'd have to hang on the prop. So I move it to right here and cover this one right here. I'm on top dead center, right? And I should get 70 over 80 if I'm lucky. But I didn't do that. I didn't do that. What I did instead is I moved it 260 degrees to right there. Now, I put my compression tester over here. What am I going to get? Right here. I'm testing this cylinder. What am I going to get on that cylinder?
That's on bottom. That's separation.
I don't know.
0.
Is the valve going to be open?
Yes.
Probably. So it's going to be about 0 over 80. Is that normal?
Yes.
Yes.
It's normal because the valves are freaking open. Got it? So the answer should be, how can this indication usually be interpreted? I'm working with an idiot. That's how it would be, who does not know radial engines. Because instead of moving the prop from here to test number 3, follow? I went all the way over to here to test number 3. And what do you get? You get dumb answers because you did the dumb thing with prop. In other words, if you're doing a compression test and you don't put it on top dead center of that cylinder, what kind of results do you expect? Good or bad? You go.
Yeah. The other side of the prop is
Who cares about that side?
still over there.
That's not relevant.
It's not.
It's not. You always go by one of the blades is that way. The other blade's doing some other stuff. Don't worry about it. That's actually bottom dead center on that blade. Because the way that the whole throw is over here to go to top dead center, so that means it pulled this piston all the way back. So if this blade is top dead center, that blade is usually bottom dead center. So what we're indicating is number 3 cylinder is at bottom dead center, and we got a bad compression.
Really?
Good.
Is that normal or abnormal? That's normal. All right. Let's see.